America has never led the world by choosing the easiest path. It is led by building, by organizing, by innovating, and by outworking the challenge in front of it. That is the spirit behind this presentation. For too long, China's manufacturing advantage has been explained in overly simple terms, as if the story begins and ends with cheap labor. But that is no longer the real story. China's advantage today is a systems advantage. It is built through industrial clustering, infrastructure readiness, logistics integration, supplier density, and coordinated execution over time. And that matters because if we misdiagnose the problem, we will misunderstand the solution. The path forward for the United States is not to chase the world downward in wages. It is not to rely on slogans. And it is not simply to move isolated factories back onto American soil and hope competitiveness returns on its own. The real challenge is greater than that. The real challenge is to rebuild an industrial ecosystem worthy of American strength. That means building a system that reduces friction, raises productivity, strengthens supply chain resilience, and restores the kind of industrial depth that has always defined great powers. It means recognizing that factories alone do not create advantage. Ecosystems do, networks do, coordination does, discipline does. This proposal is built to show how that can be done. It explains why China remains cost competitive, where the United States is still losing efficiency, and how a more integrated U.S. and Americas-based manufacturing strategy can create durable long-term advantage. This is not a call to imitate another system. It is a call to design our own better, a system built on American innovation, regional strength, strategic discipline, and measurable execution. Because the next era of industrial leadership will not belong simply to the nation with the lowest wages. It will belong to the nation that builds the smartest, strongest, and most resilient system. And America still has everything it needs to lead that future. This slide presents the central thesis of the proposal. China's cost advantage is often described as a labor advantage, but that explanation is no longer sufficient. Labor still matters, but it is not the primary reason China remains so competitive in manufacturing. The larger advantage comes from a system that is designed to reduce friction at every stage of production. China's real advantage is structural. Industrial clustering, supplier density, infrastructure readiness, and production scale all work together to lower cost, shorten lead times, and improve execution. In other words, China is not simply producing more cheaply because workers are paid less. It is producing more efficiently because the manufacturing system is more integrated. That distinction matters for the United States. If the problem is misunderstood, the response will also be flawed. Moving factories alone will not close the gap. A single relocated facility does not create competitiveness unless it is supported by a broader ecosystem that includes suppliers, logistics, workforce depth, site readiness, and speed of execution. That is why the practical strategy must be larger than reshoring. It has to focus on rebuilding the conditions that make manufacturing efficient. In many sectors, the most realistic path is regional rather than purely domestic. The United States brings innovation, advanced production, and capital-intensive capability. Mexico adds manufacturing integration and geographic proximity. South America strengthens input security through raw materials and early-stage supply capacity. The visual on the right reinforces that point. Competitive manufacturing is built across a full value chain, from inputs and components to assembly, logistics, and final market access. When those stages are closely aligned, costs fall, coordination improves, and resilience increases. So the core message of this slide is straightforward. China's advantage is largely a systems advantage. If the United States wants to compete more effectively, it must build a system that is organized for efficiency, not simply assume that relocating production will be enough. This slide explains why one of the most common assumptions in manufacturing strategy is now incomplete. For many years, the dominant belief was that China wins because labor is cheap. That idea shaped both business thinking and public policy. The logic seemed simple. Lower wages lead to lower costs. Production moves to the lowest cost workforce, and manufacturing advantage becomes mainly a labor price issue. But that explanation is no longer sufficient. Labor still matters, but it does not explain the full structure of China's competitiveness. In many sectors, wage comparisons alone create a distorted picture because they ignore the broader system that actually lowers total manufacturing cost. The real advantage is industrial. China benefits from dense supplier networks, fast production coordination, efficient logistics, strong infrastructure throughput, and scale economies that reduce cost across the full operating chain. Those conditions allow firms to move faster, source more efficiently, and reduce friction in ways that simple wage comparisons fail to capture. That is why the common belief can lead to flawed strategic decisions. If leaders assume labor cost is the primary driver, they may believe that moving production to any lower-wage country will produce the same result. In practice, it often does not, because the surrounding industrial system is not equally developed. The core point of this slide is straightforward. China's advantage is not just about cheaper labor. It is about how labor fits into a larger, more integrated production system. If strategy is based on the wrong diagnosis, the response will also be wrong. China's advantage is not built on one factor. It is built on several reinforcing drivers that work together to lower total delivered cost. That is why the advantage is cumulative rather than isolated. The first driver is supplier clustering. When suppliers are located close to one another and close to final producers, sourcing becomes faster, coordination becomes easier, and production delays are reduced. The second driver is production scale. High-volume production lowers unit cost, spreads fixed costs across more output, and creates faster learning curves across the manufacturing base. The third driver is infrastructure and port efficiency. Reliable ports, transport corridors, and industrial infrastructure improve throughput, shorten lead times, and increase consistency across production and delivery. The fourth driver is logistics integration. When sourcing, movement, warehousing, and shipping are closely coordinated, the system carries less friction, less delay, and less inventory burden. The fifth driver is policy coordination and industrial planning. Long-term planning helps align land, capital, labor, and industrial investment around production priorities. What matters most is that these drivers do not operate separately. They reinforce one another. Supplier clustering improves logistics. Scale improves infrastructure utilization. Policy coordination supports long-term investment. Together, they create the outcome shown in the center of the slide, delivered cost efficiency. The key point is simple. China's competitiveness comes from a system of mutually reinforcing capabilities, not from any single isolated factor. This slide explains why U.S. manufacturing often loses on total delivered cost, even when labor is not the only issue. The main point is that friction is embedded across the system. In many cases, the problem is not one dramatic cost driver. It is the accumulation of smaller inefficiencies that compound across the operating chain and make domestic production less competitive than it appears at first glance. The first source of friction is capital. Industrial projects are expensive to finance, expensive to build, and often slow to become fully operational. That raises costs before production ever reaches efficient scale. The second source is permitting. Approvals, compliance steps, and regulatory delays can slow projects long before any output is produced. Time lost in permitting becomes cost embedded in the final system. The third source is suppliers. When the supplier base is fragmented, coordination becomes harder, lead times become longer, and sourcing becomes less efficient. Even strong manufacturers struggle when the surrounding supplier network is weak or dispersed. The fourth source is transport. Every additional handoff between trucks, terminals, ports, rail, and warehousing adds time, complexity, and cost. Transportation friction does not just slow movement. It creates uncertainty across the entire operating chain. The fifth source is labor. Even when workers are available, companies may still face skill gaps, training delays, or difficulty staffing specialized production quickly enough to support scaling. The final source is inventory. When timing becomes uncertain, firms hold larger buffers, carry more stock, and absorb higher working capital costs simply to preserve continuity and avoid disruption. What matters most is that these frictions are cumulative. Each stage adds pressure to the next. Together, they create a delivered cost disadvantage that is often misunderstood as only a wage issue. The key message of this slide is simple. U.S. manufacturing often underperforms because friction is embedded across the system. The issue is cumulative inefficiency, and improving competitiveness means reducing that friction at every stage of the chain. This slide marks an important shift in the discussion. Up to this point, the presentation has explained why China's manufacturing advantage is rooted in system efficiency and why the United States often absorbs hidden cost through cumulative friction. The next question is where to act. The answer is not to pursue every sector with the same intensity. A disciplined industrial strategy requires prioritization. Some sectors are more important to national resilience, technological leadership, and long-term economic strength than others. Some are also more feasible to strengthen in the near to medium term. That combination is what makes them strategic opportunities. The upper right quadrant identifies the most immediate priorities. These are sectors with high strategic importance and relatively higher localization feasibility. Batteries and electric vehicle supply chains are central because they sit at the intersection of energy transition, industrial policy, transportation, and supply chain security. Medical devices belong in this category because reliability, quality control, and regional resilience matter. Industrial machinery is also critical because it supports the broader manufacturing base. Energy systems fit here as well because they are essential to infrastructure, electrification, and national capacity. The upper left quadrant identifies sectors that are strategically important but harder to localize quickly. Semiconductors and advanced packaging are among the most consequential industries in the modern economy. But they require enormous capital, specialized ecosystems, long lead times, and deep technical talent. Aerospace and defense are also vital, but they demand strict standards, secure supply chains, and high-performance industrial coordination, which makes rapid expansion more difficult. The lower right quadrant represents selective opportunity. These are adjacent sectors where targeted investments may still create value, but they do not require the same urgency or depth of localization as the highest priority industries. This is where selective, case-by-case expansion can make sense without overextending resources. The broader lesson is that not every sector deserves the same response. Strategy is not about rebuilding everything. It is about choosing where focused effort can generate the greatest economic, industrial, and national security return. The key takeaway from this slide is simple. Competitive rebuilding should be selective, intentional, and concentrated in the sectors where system design creates the greatest strategic advantage. This slide introduces the regional manufacturing model and marks an important shift in the argument. Up to this point, the presentation has focused on why China's advantage is rooted in system efficiency and why the United States often loses competitiveness through cumulative friction. The next question is what a more effective alternative model might look like. The answer is likely continental rather than purely domestic. In practical terms, the United States does not need to perform every stage of production entirely within its own borders in order to become more competitive. A more realistic and strategically effective model is to build an integrated manufacturing architecture across the Americas, with different regions performing the roles they are best positioned to support. In that model, the United States takes the highest value functions. That includes research and development, advanced manufacturing, product design, and the capital-intensive production nodes that require deep technical capability, large-scale investment, and sophisticated infrastructure. These are the areas where the United States has structural advantages and where it should remain dominant. Mexico plays a different but equally important role. It is especially well suited for assembly, mid-tier manufacturing, supplier expansion, and cross-border industrial integration. Its proximity to the United States creates a major strategic advantage. Shorter transportation distances, tighter coordination, and faster turnaround times can all improve manufacturing speed and reduce friction across the production system. South America contributes in another critical way. It can serve as a regional source of critical minerals, metals, energy inputs, and early-stage processing capacity. That matters because many strategic industries, especially batteries, electronics, machinery, and energy systems, depend heavily on upstream materials. If those materials remain concentrated in distant or geopolitically uncertain supply chains, the entire manufacturing system remains vulnerable. This is why the continental model matters. It allows the Americas to function less like disconnected national economies and more like an integrated production architecture. The United States provides technology, design, and high-value production. Mexico strengthens assembly and manufacturing integration. South America reinforces input security and upstream resource capacity. The result is a system that improves resilience, speed, and control at the same time. Resilience improves because dependence is distributed across trusted regional partners instead of being concentrated in distant external supply chains. Speed improves because production and transport distances are shortened. Control improves because the overall system becomes more visible, more coordinated, and more strategically aligned with the United States priorities. The central point of this slide is that competitiveness does not have to mean domestic isolation. It can mean building a stronger, more integrated regional manufacturing network across the Americas. This slide makes the operational point behind the entire strategy. Factories alone do not create efficiency. Ecosystems do. A country can finance plants, announce industrial projects, and build new facilities, but if the surrounding system is weak, cost and delay will still accumulate. Competitiveness depends on whether the ecosystem around production is dense, ready, coordinated, and scalable. The first pillar is dense supplier networks. When suppliers are fragmented or geographically dispersed, coordination costs rise, iteration slows, and sourcing becomes less reliable. Strong manufacturing systems depend on supplier depth around anchor industries. That is why supplier clustering matters. The second pillar is ready industrial sites. If land, utilities, infrastructure access, and permitting readiness are not in place before investment decisions are made, project timelines stretch out and firms lose momentum before production even begins. Site readiness is not a minor issue. It is a speed issue. The third pillar is fast and predictable permitting. Companies can usually manage standards and compliance requirements more easily than uncertainty. What damages execution is not only regulation itself, but slow and inconsistent approval timing. When firms cannot forecast deployment timelines, execution risk rises and investment slows. The fourth pillar is modern logistics and intermodal infrastructure. Even strong production loses competitiveness when freight movement is burdened by congestion, weak intermodal coordination, or poor connections between ports, trucking, rail, and warehousing. Logistics reliability is a core industrial capability. The fifth pillar is skilled workforce pipelines. Labor readiness is not only about having workers available. It is about having workers with the right skills in the right region at the right time to support advanced manufacturing and scale-up. Without that pipeline, capital and equipment alone cannot solve the problem. The sixth pillar is automation and digital operations. Modern manufacturing depends on precision, visibility, predictive maintenance, and integrated plant-level control. If operations lag in automation and digital coordination, productivity suffers and responsiveness declines. What matters most is that these 6 pillars reinforce one another. Supplier density improves coordination. Ready sites accelerate investment. Faster permitting reduces execution risk. Better logistics lowers delivered cost. Workforce pipelines support scaling. Automation improves productivity and control. The key takeaway is simple. Competitive manufacturing is not created by factories in isolation. It is created by the ecosystem that surrounds them. This slide translates the strategy into a measurable competitiveness dashboard. The first metric is average industrial project permitting time. The current U.S. state is shown here at 12 to 24 months. Best-in-class performance is 3 to 6 months. The 3-year target is 9 to 12 months, and the 7-year target is 4 to 6 months. This metric matters because permitting speed directly affects deployment speed and execution risk. The second metric is site readiness lead time. The current U.S. range is 9 to 18 months. Best-in-class is 3 to 6 months. The 3-year target is 6 to 9 months, and the 7-year target is 3 to 4 months. This matters because site readiness determines how fast capital can actually be placed into production. The third metric is average supplier distance from the final assembly site. The U.S. current state is 300 to 800 miles. Best in class is under 100 miles. The 3-year target is under 250 miles, and the 7-year target is under 100 miles. This is important because supplier distance is a proxy for coordination cost and sourcing friction. The fourth metric is port dwell time. The current U.S. state is 3 to 7 days. Best in class is under 2 days. The 3-year target is under 3 days, and the 7-year target is under 2 days. This matters because port dwell time measures throughput and cargo delay. The fifth metric is rail and truck handoff cycle time. The current U.S. range is 24 to 72 hours. Best in class is under 12 hours. The 3-year target is under 24 hours, and the 7-year target is under 12 hours. This is a direct measure of intermodal friction. The sixth metric is inventory days on hand. The U.S. current state is 35 to 60 days. Best in class is 15 to 25 days. The 3-year target is 25 to 35 days, and the 7-year target is 15 to 25 days. This metric shows how much uncertainty is being buffered in the system. The seventh metric is line changeover time. The current U.S. range is 2 to 8 hours. Best in class is under 1 hour. The 3-year target is under 2 hours, and the 7-year target is under 1 hour. This matters because line changeover time indicates responsiveness and operating flexibility. The eighth metric is first pass yield. The current U.S. state is 90 to 95%. Best in class is 98% or better. The 3-year target is 96 to 97%, and the 7-year target is 98% or better. This is a core quality and cost metric. The ninth metric is labor productivity per hour. The current U.S. state is indexed at 100. Best in class is 125 to 140. The 3-year target is 112 to 120, and the 7-year target is 125 to 135. This metric measures direct output efficiency. The 10th metric is apprenticeship completion rate. The current U.S. state is listed as Use Current Department of Labor baseline. Best in class is 65 to 75%. The 3-year target is plus 10 points versus baseline, and the 7-year target is plus 20 points versus baseline. This matters because it reflects workforce pipeline reliability. The 11th metric is automation density per 10,000 workers. The current U.S. state is 295. Best in class is 450 to 500. The 3-year target is 350 to 400, and the 7-year target is 450 or more. This is a proxy for production modernization. The 12th and final metric is share of critical inputs sourced within the Americas. The current U.S. state is 20 to 40%. Best in class is 70 to 80%. The 3-year target is 45 to 55%, and the 7-year target is 65 to 75%. This metric measures resilience and regional control. The reason this slide matters is that it makes the strategy measurable. Instead of talking about competitiveness in broad terms, this dashboard defines what improvement actually looks like across speed, coordination, quality, productivity, workforce development, automation, and regional resilience. The key takeaway is simple. This proposal is not just a vision statement. It is a management system with benchmarks, targets, and a measurable path from current state to competitive state. This slide focuses on sequencing. The question is no longer whether the United States should rebuild industrial capacity. The question is where to act first. The table evaluates 8 sectors across 6 decision filters: strategic importance, import dependency, build feasibility, workforce availability, time to competitiveness, and recommended action. Taken together, those measures help determine which sectors are ready for immediate ecosystem rebuilding and which ones require a longer runway. The first sector is semiconductors. In this table, semiconductors are rated high in strategic importance and high in import dependency, which reflects how critical they are to national competitiveness and how exposed the United States remains to external supply concentration. At the same time, build feasibility is low, workforce availability is medium, and time to competitiveness is long. That combination is why the recommended action is build next. Semiconductors are essential, but they require deeper capital, more specialized talent, and longer ecosystem development than sectors that can be accelerated more quickly. The second sector is battery materials and cells. This category is rated high in strategic importance and high in import dependency, which makes it a central part of the rebuild strategy. Build feasibility is medium, workforce availability is medium, and time to competitiveness is also medium, because this sector is both strategically important and realistically expandable within a shorter horizon than semiconductors. The recommended action is start here. Batteries are one of the clearest examples of a sector where industrial policy, supply chain resilience, and future mobility all intersect. The third sector is auto components. Here the table shows medium strategic importance and medium import dependency, but the sector scores high on build feasibility and high on workforce availability with a short time to competitiveness. That profile makes auto components one of the most actionable near-term opportunities, which is why the recommended action is start here. The advantage in this case is that the industrial base already exists in many areas, so rebuilding can happen through expansion and supplier deepening rather than from scratch. The fourth sector is pharmaceuticals. Pharmaceuticals are rated high in strategic importance and high in import dependency, reflecting both public health sensitivity and supply chain vulnerability. Build feasibility is medium, workforce availability is medium, and time to competitiveness is medium. That combination leads to a recommended action of build next. Pharmaceuticals matter greatly, but rebuilding at scale requires careful sequencing, regulatory discipline, and production capability that cannot be expanded instantly. The fifth sector is medical devices. This sector is rated high in strategic importance, with medium import dependency, but it also scores high on build feasibility and high on workforce availability, with a short time to competitiveness. That makes medical devices one of the strongest near-term candidates, and the recommended action is start here. The logic is that this sector combines resilience value with a realistic path to faster ecosystem strengthening. The sixth sector is electrical equipment. It is also rated high in strategic importance and medium in import dependency. Build feasibility is high, workforce availability is medium, and time to competitiveness is short. As a result, the table places electrical equipment in the start here category. This is important because electrical equipment supports broader industrial capability, infrastructure modernization, and energy system resilience, all of which make it strategically useful beyond the sector itself. The seventh sector is defense electronics. Defense electronics are rated high in strategic importance and high in import dependency, which immediately makes them a serious strategic concern. However, build feasibility is low, workforce availability is medium, and time to competitiveness is long. That is why the recommended action is build next. Defense electronics are too important to ignore, but they require a more deliberate and longer-term rebuilding path because of technical complexity, qualification requirements, and security constraints. The eighth and final sector is industrial machinery. This sector is rated high in strategic importance, medium in import dependency, medium in build feasibility, medium in workforce availability, and medium in time to competitiveness. Based on that profile, the recommended action is start here. Industrial machinery matters because it supports the broader manufacturing base. Strengthening this sector does not just improve one industry. It raises capability across many industries that depend on equipment, maintenance, and production systems. When you step back from the individual rows, the pattern becomes clear. The sectors marked start here are the ones where strategic value and practical feasibility overlap most effectively. In this table, those sectors are battery materials and cells, auto components, medical devices, electrical equipment, and industrial machinery. The sectors marked build next are just as important in strategic terms, but they require a longer development horizon, more capital, more specialized workforce depth, or more complex ecosystem coordination. In this table, those sectors are semiconductors, pharmaceuticals, and defense electronics. The point of this slide is not that one group matters and the other does not. The point is that leadership needs sequencing. Some sectors can generate earlier wins and visible ecosystem progress. Others demand deeper patience and more deliberate capability building. The key takeaway is simple. Competitive rebuilding should be staged. Start where strategic importance and practical feasibility overlap. Then expand into the sectors that require longer timelines, higher capital intensity, and deeper ecosystem development. This slide grounds the regional strategy in actual trade reality. North American integration is not a theoretical future state. It is already the operating reality. Official U.S. Census trade data show that Mexico was the United States' top goods trade partner in 2024. Total U.S. goods trade with Mexico reached $839.9 billion, representing 15.8% of total U.S. goods trade. That matters because it means the foundation for a regional manufacturing model already exists. The question is not whether the United States and Mexico can work together at scale. They already do. The second point is that the relationship is already large on both sides of the border. In 2024, U.S. goods exports to Mexico were $334 billion, while U.S. goods imports from Mexico were $505.9 billion. That level of two-way exchange shows that cross-border production, sourcing, and logistics are already deeply embedded in the operating system. The third point is that this is not a greenfield theory. Existing trade flows, supplier relationships, and manufacturing corridors already connect the United States and Mexico in practical ways. The map on this slide is meant to reinforce that reality. Corridors tied to regions such as Texas, Arizona, Nuevo León, the Bajío, and the Midwest are not hypothetical constructs. They reflect the kind of operating geography that already supports North American production networks. The strategic task now is to convert that trade volume into a more coordinated ecosystem design. That last point is an inference from the scale and persistence of current trade flows. This distinction matters. Transactional trade moves goods. Coordinated ecosystem design builds capability. Transactional trade can shift quickly when price signals change. Ecosystem design is different. It aligns production roles, supplier development, infrastructure investment, and regional specialization around long-term competitiveness. That is why the headline of this slide matters. North American integration is already the operating reality. The strategy is to deepen it. Deepening it means building on what already exists. It means treating the current U.S.-Mexico trade relationship not simply as a border exchange, but as the base layer of a more resilient production architecture. In that system, the United States can concentrate on advanced manufacturing, design, research, and capital-intensive nodes, while Mexico deepens its role in assembly, supplier expansion, and cross-border production integration. The broader implication is straightforward. The United States does not need to invent a regional manufacturing system from zero. It needs to organize the existing one more deliberately. The key takeaway from this slide is simple. North American integration is already real in the data. The strategic opportunity is to move from scale without design to scale with design. This slide explains the difference between trade activity and strategic coordination. At a surface level, both models can look productive because goods are moving, suppliers are active, and cross-border exchange is taking place. But the underlying operating logic is very different, and that difference matters if the goal is resilience rather than just volume. On the left side is the transactional trade model. This is a system driven mainly by volume and price. In that environment, firms buy and sell across borders, but the relationships are often fragmented and reactive. Supplier connections may exist, but they are not deeply organized around long-term system performance. Logistics are managed as individual movements rather than as an integrated network. Visibility across the chain is limited, which means delays, disruptions, and cost increases are often discovered late rather than anticipated early. That is why the left side includes characteristics such as volume-driven behavior, price sensitivity, fragmented supplier relationships, reactive logistics, limited visibility across the chain, and weak long-term coordination. A transactional model can support trade, but it does not necessarily create resilience. It can move goods without building a durable production architecture. On the right side is the coordinated ecosystem model. This is a system that has been deliberately designed rather than simply allowed to evolve through disconnected transactions. In this model, production roles are defined more clearly across regions and firms. Supplier development is tied to specific corridors and sectors. Logistics are planned as part of the operating system rather than treated as an afterthought. Visibility across the chain improves because participants are more aligned. And when disruption occurs, the system can respond faster because relationships, infrastructure, and decision pathways are already structured. That is why the right side emphasizes role-defined production systems, supplier development by corridor, planned logistics integration, shared visibility across nodes, faster response to disruption, and stronger resilience and control. The key distinction is not whether trade exists. It is whether the system behind that trade has been designed to perform under pressure. This matters because large trade volume by itself can create a false sense of security. A country can be heavily engaged in trade and still remain vulnerable if its supplier base is fragmented, its logistics are reactive, and its ecosystem lacks coordination. Volume is not the same as resilience. The strategic implication is straightforward. The goal is not simply to increase trade. The goal is to convert existing trade corridors into coordinated manufacturing ecosystems. That means aligning production roles, improving supplier depth, planning logistics flows, increasing operating visibility, and building a system that can respond to shocks without losing continuity. This is especially important in a North American context. The United States and Mexico already exchange goods at very high levels. But if that exchange remains mostly transactional, much of its strategic value is left unrealized. The opportunity is to deepen the relationship from a trade corridor into a deliberately designed industrial ecosystem. The key takeaway from this slide is simple. The strategic advantage comes from designing the system, not just participating in it. This slide makes the economic maturity argument behind the strategy. The United States does not become more competitive by trying to become a low-wage economy. It becomes more competitive by producing more value per hour. That is the core logic behind the formula on this slide. Competitiveness rises when productivity, quality, and speed improve, and when system friction falls. The first point is that productivity is the central lever. In BLS terms, labor productivity is output per hour, while unit labor costs reflect compensation relative to productivity. That means the real question is not whether wages are high in absolute terms. The real question is whether the system generates enough output per hour to support those wages sustainably. In 2025, non-farm business labor productivity increased 2.1%, while unit labor costs increased 1.8%, which reinforces the idea that productivity growth is the more durable path to competitiveness. The second point is that productivity does not improve on its own. It comes from how the system is designed and managed. Automation matters. Process control matters. Workforce quality matters. BLS industry data show that manufacturing performance remains uneven and that unit labor costs rose in 20% of 21 three-digit manufacturing industries in 2024, averaging 6.1%. That is why the path to competitiveness has to run through better operations, stronger automation, and more capable workforce systems, not through labor suppression. The third point is that high wages are sustainable when throughput and yield are high. A system with strong first-pass performance, low rework, faster changeovers, and better operating discipline can support higher compensation because it creates more value in every hour worked. A weak system cannot do that. That is why the formula includes quality and speed along with productivity. If output is high but quality is weak, cost rises elsewhere. If output is high but speed is slow, responsiveness suffers. And if all of that is undermined by friction, the gains are diluted. So the strategic implication is straightforward. The U.S. competitive path is not cheaper labor. It is better performance. That means higher productivity, stronger process discipline, better automation, more capable workers, higher yield, and lower friction across the operating system. The key takeaway from this slide is simple. The United States wins by producing more value per hour, not by becoming a low-wage economy. This slide defines our role in the solution. The industrial challenge is no longer simply understanding what is wrong with the current system. The more important question is how organizations actually move from industrial ambition to executable operating architecture. That is where our role begins. We are not positioned as observers of the manufacturing transition. We are positioned as advisors who help clients convert broad strategic intent into a system that can be built, measured, and managed. The first workstream is ecosystem and network design. Many clients know they want a more resilient regional production model, but they do not yet have a clear blueprint for how that network should function. The client problem is the absence of a coherent production model. Our advisory intervention is to design target state ecosystems and define network roles. The expected result is stronger resilience and better system alignment. The second workstream is site and corridor strategy. Companies often make site decisions in isolation, without fully connecting those choices to corridor economics, logistics performance, infrastructure fit, or long-term scale. The client problem is that site decisions lack corridor logic. Our intervention is to align sites to logistics, infrastructure, and scale. The expected result is better deployment speed and stronger connectivity across the operating system. The third workstream is supplier localization planning. Organizations frequently want to reduce sourcing risk and strengthen local or regional supply, but they do not always have a practical sequence for doing so. The client problem is that supply localization lacks sequencing. Our intervention is to map supplier gaps and design phased localization paths. The expected result is lower sourcing friction and stronger regional depth. The fourth workstream is operating model and KPI architecture. One of the most common weaknesses in industrial strategy is that vision is announced before execution discipline is built. The client problem is that strategy is not measurable in execution. Our intervention is to build governance, KPI systems, and performance dashboards. The expected result is greater accountability and better operating control. The fifth workstream is workforce and automation roadmap. Many organizations treat labor planning and automation as separate discussions, when in practice they are part of the same productivity system. The client problem is that labor and automation are treated separately. Our intervention is to integrate workforce planning and automation priorities into one roadmap. The expected result is higher productivity and more scalable operations. What ties these work streams together is that each one moves the client from abstract industrial intent to a more executable system. Ecosystem design creates the network logic. Site strategy creates the geographic logic. Supplier planning creates the sourcing logic. KPI architecture creates the management logic. And workforce plus automation planning creates the capability logic. The key takeaway from this slide is simple. Our role is not just to help clients think about industrial strategy. Our role is to help them build the operating architecture required to execute it. This slide shows how the engagement becomes practical. Rather than treating industrial ecosystem strategy as one broad advisory exercise, we structure the work as a phased sequence that moves from diagnosis to implementation support. That creates clarity for the client, keeps decision points visible, and makes execution more manageable. The first phase is diagnostic and baseline. This phase typically lasts 2 to 4 weeks. The objective is to establish the current state, identify ecosystem gaps, surface the main risks, and define the starting baseline. The core outputs are the baseline assessment, the risk map, and the gap scan. The client decision at this stage is to confirm priorities and validate the initial scope of work. The second phase is sector and site prioritization. This phase usually lasts 3 to 5 weeks. Here, the goal is to determine where action should be focused first. That includes sector ranking, site screening, and corridor logic. This phase helps move the work from broad strategy into more specific geographic and sector choices. The client decision is to confirm priorities, now with sharper focus around sectors, sites, and operating geography. The third phase is ecosystem design. This phase typically lasts 4 to 6 weeks. In this stage, we translate the earlier analysis into a target state ecosystem design. That means defining how the production system should be structured, how the network should function, and what the preferred operating model should look like. The key client decision here is to select the operating model direction. The fourth phase is KPI and roadmap. This phase usually takes 3 to 4 weeks. Once the target state model is defined, the next step is to make it measurable and executable. The outputs here are the KPI dashboard, the roadmap, and the governance structure. This is the point where the strategy becomes an operating plan. The client decision is to approve the metrics and sequencing. The fifth phase is execution support. This phase is the most variable and can last 8 to 16 weeks or longer, depending on the client's needs and level of support required. In this phase, we help manage execution through PMO support, governance cadence, and progress reporting. The client decision is to determine the level of execution support they want us to provide. What matters about this engagement model is that each phase produces something tangible, and each phase includes a decision point. That keeps momentum strong without losing discipline. It also gives leadership a practical way to move from industrial ambition to a system that can actually be built and managed. The key takeaway is simple. Strategy becomes commercially real when the sequence, outputs, and decisions are made explicit. This slide helps the client visualize what they actually receive through the engagement. The purpose of the work is not to generate abstract strategy language. The purpose is to deliver decision tools and operating documents that leadership can actually use. Each item on this slide represents a practical output designed to support prioritization, execution, and governance. The first deliverable is the sector prioritization model. This gives the client a structured framework for determining where to act first, where to build next, and how to sequence investments across sectors. The second deliverable is the supply chain heat map. This makes dependency concentration, sourcing exposure, and supply vulnerability more visible, so leadership can see where risk is accumulating in the operating system. The third deliverable is the site readiness scorecard. This provides a disciplined way to evaluate locations based on infrastructure, deployment readiness, and practical operating fit. The fourth deliverable is the competitiveness KPI dashboard. This is the management layer of the strategy. It gives leadership measurable indicators for tracking speed, quality, productivity, resilience, and progress over time. The fifth deliverable is the supplier localization roadmap. This lays out a phased sourcing strategy for building stronger regional depth and reducing friction in the supply base. The sixth deliverable is the executive implementation plan. This translates the strategy into sequenced actions, ownership, milestones, and execution logic so the organization can move from concept to delivery. The key point of this slide is simple. What the client receives is not just analysis. It is a set of practical decision tools and implementation documents built for execution. This slide addresses the execution reality behind the strategy. The core message is straightforward. The strategy is viable, but execution risk is real. Any serious industrial ecosystem strategy must account for the fact that strong concepts can still fail if practical constraints are not surfaced early and managed deliberately. The first risk is political inconsistency. Industrial strategy often unfolds across multiple election cycles, changing administrations, and shifting policy priorities. That means even strong initiatives can lose momentum if they depend too heavily on one political window. The mitigation approach is to build cross-cycle plans tied to economics, jobs, and regional competitiveness, rather than relying on single policy assumptions. In other words, the strategy has to be durable enough to survive political turnover. The second risk is delayed permitting. Even well-funded projects can stall if approvals, sequencing, and regulatory timelines are not addressed in advance. The mitigation here is to pre-sequence approvals, identify bottlenecks early, and prioritize ready site pathways. That reduces the chance that investment gets trapped in administrative delay before production begins. The third risk is grid and energy constraints. Manufacturing expansion depends on reliable energy, interconnection timing, and sufficient utility capacity. If the power system is not ready, the industrial system cannot scale on schedule. The mitigation is to align industrial planning with utility capacity, interconnection timing, and energy redundancy from the beginning, rather than treating energy as a secondary issue. The fourth risk is workforce shortages. A strategy can be well designed and well capitalized, but still fail if the labor pipeline is not prepared. The mitigation is to build phased talent pipelines tied to sector demand, automation needs, and regional training partners. That means workforce readiness has to be designed into the system rather than assumed. The fifth risk is capital intensity. Some sectors and infrastructure requirements demand large upfront investment and long payback periods. That creates pressure to overcommit too early or scale faster than the system can support. The mitigation is to stage investments by priority sector, corridor logic, and measurable returns rather than attempting full system overbuild from the start. The sixth risk is supplier underinvestment. A regional ecosystem does not deepen automatically just because anchor firms want it to. If suppliers do not expand capacity, capability, and regional presence, the network remains shallow and vulnerable. The mitigation is to use anchor demand, phase localization, and supplier development incentives to deepen the network over time. The seventh risk is geopolitical disruptions. Even a strong regional strategy can remain exposed if critical inputs are still concentrated in unstable or distant supply chains. The mitigation approach is to diversify critical inputs across regional partners and build visibility into concentrated dependencies before disruption occurs. What this slide is designed to show is that risk is not an argument against the strategy. Risk is part of the strategy. The important question is whether leadership can see where the constraints are, quantify their implications, and respond before they become operational failures. That is where our advisory value becomes practical. We do not claim that risks can be removed entirely. We help clients make risk visible, measurable, and manageable. The key takeaway is simple. The strength of the strategy is not that it assumes a frictionless path. The strength of the strategy is that it acknowledges execution risk and builds mitigation into the operating design. This slide presents 3 plausible pathways to competitiveness and explains the trade-offs between them. The purpose of this comparison is not to suggest that only one option exists. It is to show that there are multiple strategic pathways, each with different implications for capital, timing, resilience, control, and long-term value creation. The first scenario is the conservative path. This is based on selective reshoring. In practical terms, that means bringing back specific production categories or isolated parts of the supply chain without attempting to redesign the broader ecosystem. In this scenario, the capital requirement is scored at 2. The reason is that selective reshoring usually involves narrower investment, fewer supporting systems, and less infrastructure build-out than the other options. Its implementation speed is scored at 4 because it is relatively fast to initiate. Companies and policymakers can move on selective product categories more quickly than they can build full cross-border or sector-wide ecosystems. Its geopolitical resilience is scored at 2 because selective reshoring reduces some exposure, but it usually leaves major upstream dependencies and broader supply chain vulnerabilities in place. Its supply chain control is also scored at 2. That is because this model does not fundamentally redesign supplier networks or regional operating architecture. It improves control in limited pockets, but not across the full system. Its economic impact is scored at 2 because the benefits are real but narrow. This path may create targeted gains, but it is less likely to generate broad industrial multiplier effects. The second scenario is the integrated path. This is the U.S.-Mexico corridor build-out model. It assumes that competitiveness is strengthened through regional production design, not only through isolated domestic relocation. Here, the capital requirement is scored at 3. It requires more investment than selective reshoring because it depends on corridor coordination, supplier development, logistics integration, and cross-border ecosystem design. But it is still less capital-intensive than a full transformation. Its implementation speed is scored at 4. The reason is that this path builds on trade flows, industrial corridors, and supplier relationships that already exist. It does not require creating an entirely new system from zero. Its geopolitical resilience is scored at 4 because regional diversification across North America materially improves resilience compared with distant external concentration, even if it does not eliminate all exposure. Its supply chain control is scored at 4 because this model creates stronger visibility, tighter logistics, and better coordination across a regional production system. Its economic impact is also scored at 4 because the model creates broader benefits than selective reshoring. It supports manufacturing, logistics, supplier expansion, and regional capacity building at the same time. The third scenario is the transformational path. This is the most ambitious model and assumes full ecosystem development in strategic sectors. Its capital requirement is scored at 5. That is because it requires large-scale investment across sites, suppliers, workforce pipelines, automation, infrastructure, and supporting systems. Its implementation speed is scored at 2. The reason is not that the model is weak, but that it takes time. Deep ecosystem development is slower because it involves more moving parts, more institutions, more build-out, and more coordination. Its geopolitical resilience is scored at 5 because this path provides the strongest structural improvement. It reduces concentrated exposure the most and builds the deepest domestic and regional capability. Its supply chain control is also scored at 5 because it gives the strongest long-term control over sourcing, network design, and production continuity. Its economic impact is scored at 5 because it creates the largest long-term upside. It has the greatest potential to strengthen industrial depth, productivity, employment, supplier capacity, and national resilience. When you compare these three scenarios side by side, the pattern becomes clear. The conservative model is faster and cheaper, but it produces limited structural improvement. The transformational model produces the strongest long-term gains, but it requires the most capital and the longest execution timeline. The integrated model sits between them. It is more substantial than selective reshoring, but more practical than full transformation. That is why the integrated path often emerges as the most balanced option. It offers meaningful improvement in resilience, supply chain control, and economic impact, while still remaining grounded in an implementation model that can build on existing trade corridors and real operating relationships. The point of this slide is not that one scenario is universally correct in every case. The point is that leadership needs to understand the trade-offs clearly. Competitiveness is not a slogan. It is a strategic choice about how much to invest, how fast to move, and how much structural change is actually required. The key takeaway is simple. Different pathways produce different outcomes, but the strongest practical path is often the one that balances feasibility with strategic depth. This slide presents the strategic recommendation. After reviewing the economics of competitiveness, the operational requirements of ecosystem design, the role of regional integration, the practical engagement model, the likely risks, and the scenario alternatives, the recommendation is clear. The strongest practical path is ecosystem first, regionally integrated, and sector prioritized. That phrase is important because each part of it solves a different problem. First, the strategy should be ecosystem first. That means the goal is not simply to fund factories or announce reshoring targets. A factory by itself does not create competitiveness. Competitiveness comes from the surrounding system: supplier networks, site readiness, logistics, workforce quality, automation, infrastructure, and management discipline. If those supporting systems are weak, then even well-capitalized projects struggle to reach scale efficiently. An ecosystem-first strategy recognizes that industrial success is created by operating architecture, not by isolated assets. Second, the strategy should be regionally integrated. The most practical path is not to treat competitiveness as a purely domestic exercise. The United States already operates inside a larger North American trade and production reality. That existing foundation should be deepened, not ignored. Regional integration allows the United States to anchor the highest value functions: research, design, advanced production, and capital-intensive nodes, while building stronger corridor density, supplier development, and production coordination with regional partners. This improves resilience, speed, and control more effectively than trying to localize every activity within one national boundary. Third, the strategy should be sector prioritized. Not every sector deserves the same level of attention, investment, or localization depth. A universal reshoring strategy would spread resources too thin and weaken execution. The better approach is to focus on sectors where speed, security, and control matter most, especially where the overlap between strategic importance and practical feasibility is strongest. That is what makes the strategy disciplined rather than symbolic. The recommendation statement on this slide brings those three ideas together. The most practical path is to build competitiveness through targeted ecosystem development across priority sectors, anchored in North American integration, and managed through measurable operating outcomes. That means the strategy is not broad for its own sake. It is targeted, it is regionally grounded, and it is governed through performance. The first supporting point is do not pursue universal reshoring. That is a critical discipline point. The objective should not be to bring everything back indiscriminately. Instead, the focus should be on areas where localization creates the highest strategic return. That preserves capital, talent, and execution capacity for the places where they matter most. The second supporting point is prioritize sectors where speed, security, and control matter most. Some sectors are more important because they shape national resilience, supply continuity, technological capability, or strategic independence. Those are the sectors where ecosystem development should begin. Sequencing matters because industrial policy fails when it tries to advance every category equally. The third supporting point is build North American density first. The most realistic way to improve competitiveness at scale is to strengthen regional corridors, deepen supplier networks, and increase operating coordination across North America. That creates a more practical and faster route to resilience than waiting for a purely domestic-only model to mature. The fourth supporting point is tie incentives to measurable operating outcomes. Competitive rebuilding cannot be managed through aspiration alone. Incentives should be tied to results such as permitting speed, site readiness, supplier depth, productivity, resilience, and execution progress. And those outcomes should be governed through KPIs, milestones, and accountability. This is what makes the recommendation commercially and strategically credible. It does not rely on rhetoric. It relies on prioritization, regional design, measurable execution, and disciplined operating logic. The key takeaway from this slide is simple. The recommended path is not broad reshoring for its own sake. It is targeted ecosystem development in priority sectors, built through North American integration and governed through measurable outcomes. This presentation began with a simple question. Why do some nations sustain manufacturing advantage while others struggle to rebuild it, even when they have talent, capital, and political intent? The answer is now clear. The next manufacturing advantage will not belong merely to the country with the lowest wages. It will belong to the system that is best designed. That is the real lesson running through everything we have covered. China's advantage is not just cheaper labor. It is system design. It is supplier density. It is infrastructure readiness. It is logistics integration. It is production scale. It is speed. It is coordination. It is the ability to move from ambition to execution with fewer breaks in the chain. And that is also the American opportunity. The United States does not need to become a low-wage economy to compete. It does not need to imitate every feature of another system. And it does not need to chase the illusion that every factory, every supplier, and every strategic input must sit within one national border to create strength. What it does need is discipline. It needs the discipline to choose the right sectors. It needs the discipline to build ecosystems, not isolated facilities. It needs the discipline to use North American integration as a strength rather than treating geography as a constraint. And it needs the discipline to govern industrial strategy through measurable operating outcomes, not rhetoric, because this is the real dividing line. There will be organizations, regions, and leadership teams that continue to talk about competitiveness in broad terms. More jobs, more factories, more reshoring, more investment. But broad language is not the same as durable advantage. Durable advantage is built when the system is designed with intent, when suppliers are placed deliberately, when sites are selected with corridor logic, when workforce pipelines match production needs, when automation supports throughput, when incentives are tied to outcomes, when execution is governed, measured, and improved. That is what turns aspiration into capability, and that is why the stakes matter. This is not only about supply chains. It is not only about trade. It is not only about industrial policy. It is about whether leadership can build an operating system strong enough to support resilience, productivity, and long-term control in a more competitive world. The winners in the next era of manufacturing will not simply be the ones who spend the most. They will be the ones who design the best, The ones who understand that factories alone do not create efficiency. Ecosystems do. The ones who recognize that competitiveness is not a slogan, it is an architecture. That is where we come in. We help leadership teams identify where competitiveness can be built, how it should be measured, and what sequence of actions creates durable industrial advantage. Not in theory, in execution, in metrics, in site logic, in supplier depth, in corridor design, in operating governance, because the next manufacturing advantage is not waiting to be discovered. It is waiting to be designed. And the question now is not whether that system can be built. The question is, who will build it first?